Hi, this is Andrew. Thanks for joining me. This video covers manual data carving as part of forensics. Normally when we do forensics, we'll be using a much larger utility that can catalog and find anything that we've deleted, anything that is any piece of evidence on the image of the computer that we're looking at. In this case, we're going to manually data carve so we can see a little bit of what those programs are doing in the background, and also so you can manually see the process of taking something that was deleted and finding it on a drive. So first thing we're going to do is look at what we're going to be looking for. So if I take a look, I have HXD right here, and I have a folder with a few pictures in it. So I'm going to I'm going to drag one of the pictures into HXD, and let's do this one. And you can see the hex of that JPEG. And it starts out with FFD8 FFE0. That's how JPEGs start out typically. And if you go down to the end of the picture, you can see all kinds of stuff in there that any program will convert into the picture. At the end, it ends with FFD9. That's something we're going to need to be aware of for later on. So with that said, now let's take a look at the drive we're going to use. So I have right here on this computer, I have a USB drive plugged in. I select the USB drive and it is empty. If I want to confirm that it's empty, I can actually look at the hex of that. So I'm going to relaunch HXD, but I need to launch it as an administrator. So here's HXD running as administrator, and if I go up to Tools, I can open Disk, and I'm going to select my removable drive, and it's actually a 32 megabyte USB drive. It's very old, still works really well for this type of activity. So I can select OK, and I see there's formatting information. This is just information about the drive itself. And there's the error that you get if you try to boot from it. But then we go down, and it's all zeros. It's been overwritten. One section of it has just some characters there, but it is completely blank. So that is confirmed. We don't have anything on here. So now we can copy some files to this. So again, I have the D drive there. That is my USB drive. I'm going to open up this pictures folder again. And I have three pictures here, three JPEGs. Picture of a computer, a picture of a lake, and a picture of a turkey. So I can copy them over to the USB drive, and now they're on there. Now, if I launch Hexden again as administrator, I'm going to do that right now. So Hexden running as administrator, I can once again analyze the disk, the removable disk. So now if I were to scroll around, I would see that there's things on the disk, and I can scroll down and I can see I have a bunch of things here. The problem is, if I were to look for FFD8 FFE0, it would be hard to find. So what I'm going to do is start at the beginning. That's where my cursor is. And I'm going to do a search. I'm going to do find, and I want to type FFD8 FFE0 here. But I'm not searching for text string. I want to search for a hex value. So this first tab is text string. I want to search for a hex value. FFD8 FFE0. So now I click OK, and I found the start of a file. This is the start of a JPEG. And FFD8 FFE0. Now, later on when I search for it, I'll actually make note of the spot that it's stored in, and then I'll scroll down to the end of that file and be able to find the end of the file. But it's not something I need to worry about right now. First thing I want to do is I will close this, and I'm going to go back to my D drive. I have my D drive here. I have the three pictures on there. I'm going to right click on the drive, and I'm going to go up to Format, and I'm going to format the drive. I'm going to do a quick format because a non-quick format would actually overwrite all zeros. I'm just going to do a quick format, and format complete. Now, if I go to the USB drive, it's empty. So you might think everything's gone, everything has been deleted. But let's take another look at the hex of the drive. So I'm going to launch Hexden as administrator again. And with it running as administrator, I'm going to open the disk again. I select my removable disk. And now I'm going to scroll down and see. And I still see a bunch of stuff there, even though I formatted the drive. And if I go back to my search, I can do edit or search and find. I'll select hex values. And I should have that stored. I have FFD8, FFE0, and I select OK, and I get that again. So that's still there. So I can still see things that are there, and I could start data carving here, but that's not what I want to do. In general, if I found this USB drive, the first thing I want to do is create a forensic image of it. If I'm playing with this drive and I make a mistake, or I change something, or my computer writes something to it, it's no longer a true image of what was originally there, and that could be called into question in a court of law. It could be questions like, are you sure that this was on the drive when you got it because you were playing with the drive? Did you do anything to prevent it from being changed? So in this case, what we're going to do is we're going to use Access Data FTK Imager. FTK is their product forensics toolkit, and we're going to create an image of that drive, and that's going to be the image is a file that is an exact copy of what is on that USB drive. So I am going to create a disk image. I'm going to do it of a physical drive. I'm going to select the drive, and I need to make sure I select my SanDisk Cruiser USB Mini 32 meg USB. The other ones were drives in my computer. I don't want an image of those drives. I want an image of this USB drive. So select Finish. Now I need to give it a destination. I'm going to say I can do different file formats. RAW would be a problem if I didn't have enough hard drive space. I could do other types of images that would be smaller, but RAW is going to work fine in this case. I'm going to call this case 1. Evidence item number is 1. Description is SanDisk 32 MB USB. And examiner is Andrew, and notes, we don't need any. So now I need to store it someplace. I'm going to browse, and I'm going to create a place to put it. So I created a folder called disk image on my C drive, and now I need to give it a file name, and I'm going to do item 1. Now I can break it into smaller pieces if it's a large file, if I want to store them on, if I wanted to burn copies on DVD drives or put it on whatever, I can break it into pieces. I don't need to worry about that. It's a 32 meg file. I can use encryption if I wanted to. I don't need to do that either. So I'm going to select Finish. Now I'm creating this disk image, and I can start. So it goes through the process. If this were a very large disk, this would take a very long time. Since it's a 32 meg disk, it was very quick, and it created hashes that I can compare the hash of the device, and the hash is just a mathematical calculation done on the disk to create a fingerprint. And if we do the same calculation on the file that was produced, the hash would match, and that is what we're seeing here, the computed hash and the reported hash. And I will leave this up. I'm going to open up HashCalc, and I'm actually going to compare that file. So if I go here, I'm going to find the file now, and I can go to disk image, and this is my image. This is information about my image. If I open this, I can see what created the image, what my description was, my case number, my evidence number, examiner, and here's the computed checksums, that the MD5 and SHA-1, when it was acquired, all of the information, and then we look at the image itself and say disk image 1, item 1, 001, and those are our numbers. So if I look at this and I create the hash calc on that, it does the calculation, and these numbers all match. Well, I don't have an MD5, so let's calculate an MD5. MD5, E6A0, and ending in 8C6F4. If you can see it on the screen, you can do a full comparison. Everything's probably a little bit small, but F3 3B and EB7C. You can go through each character and they would all match. So those are the hash values. We have now confirmed this image is exactly what we had from the USB drive. So we matched it exactly. We're sure of that exactly. So let's clear some things out of the way. I can close this, and I can close this, and I can close this. And now we have our image, so now I can even close FTK. Now I have this image here. What I want to do with it is actually start creating, carving the data out of it, carving those images out of it. We saw that that image doesn't have anything in the file system. We look at our pictures directory, we look at our USB drive, and it's empty. And this is the same thing. But if we go in deeper and examine this, so I have HXD open, and I opened Notepad and I put them side by side. We're going to use Notepad to keep track of where things are, because that's a little bit easier than trying to use pen and paper when you can't see what I'm writing. So I will now open up that image 1. This is the file that we created with FTK Imager. So I want to now search for the beginning of that JPEG, or one of the JPEGs. I can select hex values, FFD8, FFE0, go down here, and this is my offset. This is the beginning of the JPEG file. So I'm going to type start over here, and I don't need the 00. I'm going to do 2900800. That 00 is actually which column this is in. So that's the first column, or the first column in the 2908 row. Now what I need to find is the end of the file. So I'm going to do search, find, and I need to type FFD9. That's the next thing I want to find. When I select OK, actually what I see here is I see that character kind of in the middle of the file, which throws things off. I don't think that's the, we were at 2908 and now we're at 2940. That's not a lot. So I'm actually going to search for the next one. And when we get to the next one, we see we actually have a bunch of zeros there. So that's kind of a file separator. And then we can actually see the beginning of the next file. So I don't need to write down the end of this one, the 32AFD0, because we're in the D0 column, but we are actually in the 06. I don't need to write that down because I can go here and I can select block. By selecting a block, I'm going to select a chunk of what's in there. One way I could do this is I could say, okay, I'm going to click on this and drag it all the way up until I get to my 290800 part of the image. It's a really big file. It's going to take a while to do that. So I'm going to do select block instead. And I can say 290800, and it's hex. I don't need to worry about the length because I have a start offset and an end offset. The end was populated because that's what's highlighted here. That's what went in here, and I changed the start. So now when I select OK, that highlights the whole thing. I can right click that and copy. Now I need to paste it somewhere. I could paste it into Notepad, but that really wouldn't work the way we'd expect because Notepad only deals with text, and this is hex that I'm pasting. So what I can do is create a new file. I have a blank file here, paste, insert here, and I have a file that starts, it ends with FFD9, and it starts with FFD8, FFE0. So HXD does not know that this is a JPEG. It doesn't know anything about it. We just pasted a bunch of stuff in there. So its name is untitled. What I can do now is save that. And if I save it into the same directory, I can give it a file1 name. And I want to give it, if I don't give it an extension, Windows won't know what it is. So I'm going to give it a JPG extension. And when I save this, it's saved into that directory. Now, if I open up that directory, I see that file1 was my computer image. So it looks exactly the same. If I look at the sizes, they're the same size. I could do them side by side. That's the same picture. So now I know I can go back to my image, and I already know the next one is right here at, we'll call this start 2 is right there, 32B000. 32B000. And now the next thing I need to do, I didn't need to search because it was so close. Now I can do search and find the end again, FFD9. So I get down here, FFD9, and I have a whole bunch of zeros after that. So let's do the same select a block. And right here, see, it's the same, it puts the same in both. It doesn't know whether this is going to be your start or your end. Since it's the end, I leave that there, and I change the start to 32B000. That's what I put in Notepad. I select OK. I have the whole thing selected. Copy. Let's do a new. So I right click, I paste. I'm going to insert, and I see that it ends with FFD9. That's the end of the JPEG. If I go back to the beginning, I can see that it starts with FFD8, FFE0. That's the start of the JPEG. Now, it is possible that the offset is different, and it was actually, there were a couple of spaces in here or other characters in here. I might need to delete them out, and if I can highlight and delete, and that's gone. In this case, I do need that, so I'm going to undo that. But if there were characters in front of my FFD8, FFE0, I might need to remove them. So again, I'm going to save and give this a file2.jpg name and save it there. And when I go back to pictures, file 2 is the turkey. And if I open up the turkey picture, file 2, that's what it looks like. The original file was exactly the same. So side by side, and if we looked at the exact properties of it, we would see exactly the same file because the hexadecimal is exactly the same. Nothing has changed by copying the file, by deleting it, or doing anything with it. So we just carved out 2 of those images from an image of a USB drive that was showing that it was completely empty. This is our USB drive, still empty. I could go in here and do the same thing. If I were to start a new investigation, I would, or if I went away to lunch and came back, I would check the hash value to make sure they match the image and whatever my documentation is, and I would probably make note of that I did verify that the hash value matches what I originally calculated when I created this disk image. Every time I go in and do something, I would verify that this is correct. I would maybe perform another verification. So this is the process of manual data carving, of taking things that have been deleted from a disk and recapturing them. So that's all I have for you today. Thanks for watching.